computing, a Snowflake schema is a logical arrangement of tables in a multidimensional database such that the entity relationship diagram resembles a snowflake shape. The Snowflake schema is represented by centralized fact tables which are connected to multiple dimensions. Snowflaking is a method of normalizing the dimension tables in a star schema. When it is completely normalized along all the dimension tables, the resultant structure resembles a snowflake with the fact table in the middle. The principle behind snowflaking is normalization of the dimension tables by removing low cardinality attributes and forming separate tables. The Snowflake schema is similar to the star schema. However, in the Snowflake schema, dimensions are normalized into multiple related tables, whereas the star schema's dimensions are normalized with each dimension represented by a single table. A complex snowflake shape emerges when the dimensions of a snowflake schema are elaborate, having multiple levels of relationships, and the child tables have multiple parent tables. Star and snowflake schemas are most commonly found in dimensional data warehouses and data marts, where speed of data retrieval is more important than the efficiency of data manipulations. As such, the tables in these schemas are not normalized much, and are frequently designed at a level of normalization short of third normal form. Normalization splits up data to avoid redundancy by moving commonly repeating groups of data into new tables. Normalization therefore tends to increase the number of tables that need to be joined in order to perform a given query, but reduces the space required to hold the data and the number of places where it needs to be updated if the data changes. Some database developers compromise by creating an underlying Snowflake schema with views built on top of it that perform many of the necessary joins to simulate a star schema. This provides the storage benefits achieved through the normalization of dimensions with the ease of querying that the star schema provides. The trade-off is that requiring the server to perform the underlying joins automatically can result in a performance hit when querying, as well as extra joins to tables that may not be necessary to fulfill certain queries. The primary disadvantage of the Snowflake schema is that the additional levels of attribute normalization adds complexity to source query joins. When compared to the star schema, Snowflake schemas, in contrast to flat single table dimensions, have been heavily criticized. Their goal is assumed to be an efficient and compact storage of normalized data, but this is at the significant cost of poor performance when browsing the joins required in this dimension. This disadvantage may have reduced in the years since it was first recognized, owing to better query performance within the browsing tools. When compared to a highly normalized transactional schema, the Snowflake schema's denormalization removes the data integrity assurances provided by normalized schemas. Data loads into the Snowflake schema must be highly controlled and managed to avoid update and insert anomalies. The example schema shown to the right is a snowflaked version of the star schema example provided in the star schema article. The following example query is the Snowflake schema equivalent of the star schema example code, which returns the total number of units sold by brand and by country for 1997. Notice that the Snowflake schema query requires many more joins than the star schema version in order to fulfill even a simple query. The benefit of using the Snowflake schema in this example is that the storage requirements are lower, since the Snowflake schema eliminates many duplicate values from the dimensions themselves.